So we talk about binary data management in Oak today, and I have with me on stage, well actually I'm on stage with you.
Well, yeah. An old picture of me back when I had long hair, and before I worked at 3 startups, so I have a lot less gray in that picture than I do now.
Okay, so I have the same picture as well. It's even fuzzy. So I'm with NetCentric CTO there, Sling since it was called MicroSling, so for a while, and the whole Jackrabbit thing before as well, and some record in large-scale enterprise situations that don't work out in the end. And then this is why we talk a lot about things that are going forward.
Yeah. And this is the slide that my boss told me I had to put in. We're going to talk about some stuff today that is pretty new. It doesn't constitute promised features for AEM. I think we all understand that. So,
yeah. Okay, so what else do we have today?
Well, one of the things we're going to talk about today is this idea called the Composite data store. That's something that I've been working on for a little while. We're kind of excited to show. It's not in Oak yet. It is coming hopefully pretty soon, but there's a number of decisions that we have to make on implementation, so that'll take a couple of months probably before it's in Oak, but hopefully it'll be in for 1.8. And then after that, if we have time, we're going to talk about some other data management challenges that we see in Oak, things that we have been talking about in the team, and some things that we hope will come in soon. We don't know exactly when, but some things that we're working on and talking about. Time at the end for questions.
Yeah, so the disclaimer is clear, so this is all brand new, not in somewhere really, but coming hopefully soon because we need it.
Yeah.
So talking about needs, Composite data store. Let's do a quick wave. Who is using Sling not for content management? Okay, so I would quote this 100%, even the guys in the technic behind you using it for CMS usage. So who is not working on AEM at all? 2. There's another CMS somewhere. Where's Ralph? Not here. So a couple of CMS out there that are not AEM, but still working. So if you work with AEM, over time, very quickly you come to a point where it grows. We have seen the data store separation in a previous talk, and now it is about, okay, what actually happens when you separate your data store out? Everything is fine, and then the instance grows. So who has worked with a larger instance than 100 gigs? Okay, so I would say almost half of us. So someone in the terabyte area? More than 10? Okay, so yeah, the firsts are out there. So it's coming. So if you look at the roadmap of Adobe, assets is a big topic. Assets always means like big data, videos, everything. So and then you come to the point where it's like, great, I have my super large instance. I have everything DevOps. Everything is working fine. I have my downstream. I have my production system. And then I go with my test system. I have weekly updates only, not nightly, but weekly copies of my data system down there. So now you realize, okay, so most of the stuff is sitting on S3. So you have 10 terabyte on S3, and you want to have a weekly copy of it. So sometime you probably get off it, and it doesn't work, and it takes too long, and it costs too much, and then you figure, ain't no work anymore. So, and then you think of, what can we possibly do about this topic? So you have large instances. You still want to have good copies, quick tests. How do you do it?
So that question and a couple of others are kind of what has prompted this idea of the Composite data store. So this one here is the one that Conrad was just speaking about. There's some other ideas that maybe you've thought about, like how if I want to have archives, but I want to be able to see my archives as well as my recent data, how can I see them all together? Or is there a way that I can use different criteria to decide where data should be stored? besides just using the size of the blob. That's kind of where this idea for composite data store came from. This is what it looks like. You can think of it as a logical data store with delegates inside, 2 delegates at least. If you only have 1 delegate, it doesn't make any sense to have the composite. But these delegates are just normal data stores, so they can be file data store or S3 or whatever. And to be clear, these are data stores that are separate from your MK, as Valentin and Michael just spoke about. So this is basically what the composite looks like. It's a pretty simple idea, but there are some interesting use cases that you can get with this. So the one that we have spoken about, the one that we will demo in just a minute, is this testing environment where I would like to have a test instance that looks just like my production instance, but it's time or cost prohibitive to duplicate my entire data store because it's so big. So what if my test instance could access the production data store in a read-only fashion? So this is what we're talking about. I've got my production environment here with a separate node store and a separate data store. And when I want to create my test environment, I do the snapshot here of the node store. That's really fast. It doesn't take long to do at all. But I don't want to try to do the snapshot of my production data store because it just takes too long. Even if you're doing them weekly, like Conrad was saying, once it gets to a certain size, you can't even finish before you have to start over. So what we want to do instead is use the composite data store, which would have 2 delegates. It would have a test data store here, and then the other delegate would be the production data store in read-only fashion. So when this test environment here uses that composite, all updates end up here, but it sees all of the production data read-only and presents all of that data in one logical view. So when this test environment first comes up, it looks exactly like production. You can make all the changes you want. None of those ever end up here. When you're done with the testing, you can throw that test environment away and start over, and you'll look just like production again. So that's one use case. Here's another one. We talked about automatic archiving. So let's say that you have some mechanism where you are archiving less frequently used binaries out of your data store to some other location, but you'd still like to be able to see your archive data all in one view in your Oak instance. So this is maybe a kind of an explanation of how you might be doing that. In this case, we're saying that you've got 3 S3 containers. 2 of them are buckets, so you've got one that's got all of my S3 data, and then you move your data somehow, maybe through a script that you wrote or through AWS Lifecycle Management policy, to a different bucket that's using infrequent access storage. And then let's say that after some further period of time, you move that over to Glacier. Now, in order for this to work with the composite, we would need a Glacier data store, which we don't have yet, and I don't currently have concrete plans to do something like that. But let's say we had a Glacier data store. So in this case, how that would work with the composite is you'd have 3 delegates, and when a request comes in for a resource, Oak would ask the composite, and it would look first in the
primary,
the hierarchy. Yeah. So the first one in here, and if it doesn't find it here, then it would go here, and if it doesn't find it in infrequent access, then at the last resort, it would look for it in Glacier. But again, all of those get presented as one logical view, so it all looks like one data store from the user's perspective. Another use case, a way to designate, this one talks about a way to designate certain data for highly available storage. So we know that a few months ago, there was a big outage in S3. I don't know if that impacted Europe as much as it did in North America, but it was a big deal for us over there when the whole East region went out. So you might be feeling like you don't want to ever be subject to that again. you would like to be sure that you have geo-redundancy on your data stores, but you don't want to pay to put all of your data in geo-redundant storage, because that would be really expensive. So what would be nice is if there was some way to select which data you wanted to be stored geo-redundant. If you used Azure, for example, then you might be considering something like this. You've got 2 different storage classes. There's a couple more actually, but these are the basic ones. LRS in Azure is the locally redundant storage. So it's in one region, and it's redundant, but just within the one region. GRS is geo-redundant storage. It does the same local redundancy, but then it replicates that in a separate geo. And Azure handles the failover for you. So if Azure determines that one geo has gone down, it will automatically route requests to your second geo. You might think that would be great for you, but of course, GRS storage is about twice as much as LRS, and you don't want to put all of your assets there. So what can you do?
Because if you have 10 terabytes, most of it will not be
Right.
accessed all the time. So if you're a hot data, and you have a lot of stuff that just sits there and you cannot delete because of archiving reasons or whatever. So if you have 10 terabytes, most of it is actually not used data, is a series. So, and then you pay very expensive storage for exactly that topic. So
Right, right. So here's an example of what we might be able to do. This would require a capability in Oak that we don't currently have, and we still need to discuss as a team how we would be able to support this. But let's suppose that at the time a binary was stored, we knew things like properties that were on the node for that binary. If we knew that, then we could designate binaries with something like this and say that we're going to put a property HA equals true on binaries that we would like to be put into geo-redundant storage, and then have the LRS as the default. So what would happen is I get a binary in over here on this side, and when we go to store that, we recognize that doesn't have that property, so we're going to put it into the local redundant storage. But when this other one comes in and it has the property, we recognize that it matches that, and that one automatically goes into the geo-redundant storage. So just by designating with a property the ones that we want to go into highly available storage, we could use the composite to store all of those in the expensive storage and take advantage of geo-redundancy. But at the same time, most of the data that we don't want to go in there will automatically go in the less expensive storage. A similar type of problem would be just storing binaries by type. So this might be, you would like to have your
Since the expensive movies somewhere else
Yeah.
than all the data you use very often. So that would be a classic by type separation, I would say.
This is like a kind of an AEM example. You just say, I want to put everything in content DAM with that path. Anything under that path goes into S3. And all of my other data just stays on my file data store. So all your index segments and bundles and everything would stay local. So those are some examples of how we might be able to do that. And Conrad is going to give us a demo on how that works.
Okay, let's see how it works. So you should see everything mirrored, so that's fine. So what I would like to demo you is quick test setup. So I mimic a production test system. So I have my production copy, and the production copy has that production data store attached, as we just heard in a previous talk, absolutely essential for every installation. So for better visibility, I actually pulled it up somewhere else. This could be an S3 data store or anything. This is just the data store. And then I have my test, my prod instance, 16 gigs, and my test instance, 16 gigs. So, and on the production instance, this is actually the system that has all the great images of yesterday. So if you see here, we have adaptTo and we have day 1. So now we have the interesting question of what happens if we have day 2? Can my system still handle it? So what do I do? So what I go now is I'm going to clone the environment down. So let me quickly be complete and stop my production instance. So you see on the right-hand side production instance, and you should see on the left-hand side my test instance. So what I'm going to do is, I'm a big fan of rsync, so I sync over the segment store just from production to my test system, and that's it. So no touch. If you look at the disk usage, so it's still the same, so they're identical right now. So I'm starting up my test system. So, and this is nicely pre-configured with stuff like, as of course my run modes I want with test, a different port, so all the good things you would expect, something like that. Okay, so while this is starting up, I actually do the same with my production instance. So now I have two instances running. Give it a second to actually start up. Still starting up, apparently. Have you seen this before? It's a 503 feature. It's great. It helps load balancer to know when they should not hit it, different than the 404 feature you've seen before. So this one is still on a kind of a 404 feature, the test system, right? And the other one is on a 503. So once they are up, so we have now two copies. You can see, so this is my test system on the right tab and my production system on the left. I'm going to an asset instance, files. I see my adaptTo folder, day one, and this is it. So I have two identical copies. That view disk usage still looks almost the same. So the test system already modified some data on a boot. But now it's getting actually really interesting. So what happens if I decide on a test system actually to take Stefan and go somewhere and it's like, you know what, sometimes your world is actually flipping over. Really great. You can still read the adaptTo, but it's the high-hanging fruit now. So this is my test system. This is my production system. So obviously on the production left-hand side, it's still unmodified. If I go and close that one on the right-hand side now, you can see this is really cool stuff. He's hanging low and fine now. So on a disk usage, you see some more modifications going on in that data store test, while the production has not changed at all. So, and you can take this example for, you could do uploads now, test things, you modify data, and you don't have to download the whole S3 to somewhere or make copies or whatever, and you can work with an S3 data store as a primary source, or as the actually secondary source. And you have the primary data source, your read and write data store, which could be S3, could be a local file data store, or whatever. It's pretty much it, sir. Did I forget something?
No.
Cool. So let's go back to slides.
Yeah, so like I said, the status of that is that, well, honestly, the status is that I was trying so hard to get this done for today that
we need to align
there's a
with
number
the
of discussions
community.
that we need to have on the Elk team that we
Yeah.
haven't had yet. So it's gonna be a bit, but I'm hoping that we'll have this in pretty soon. So that's the status of it. Okay. So having covered that, there's a couple of other topics that I kind of want to cover a little bit. There are some other data management challenges that we have talked about in the Oak team. And to be fair, I'm pretty new on the Oak team. I've only been with Adobe for a year and a half. I work on Oak probably about half of the time. I have other things that my bosses pull me into. I have two bosses, so that's part of the challenge, is that they're both sometimes pulling me in different directions.
Like gives it 50% each, right?
Yeah, exactly.
In theory.
So I want to be fair to the rest of the Yoke team who have done a lot of work before I got here, and they have been talking about these things a lot longer than me. These are, many of you I'm sure have seen these challenges, things like this. I kind of distill them down into two topics. One has to do with how do you quickly add a large content repository to Oak, or AEM or whatever. And the other one has to do with how do you responsibly allow direct access to binaries that are that are managed with Oak. So let's talk about the first one. This is what the problem kind of looks like. Let's say that you've got a very large existing repository of data. It's in S3. You're not using Oak or really any other thing necessarily to manage it. You just have a whole bunch of content, and it's already organized hierarchically and everything. And what you would like would be to just spin up an Oak instance and have it manage this repository. But in order to do that, you have to take all of the data that's in S3 and you have to upload it all through Oak back into S3. And we understand why that is the case, but for many users it seems kind of counterintuitive because you're putting it back where it already was. And this is really expensive in terms of time and money. The other problem has to do with responsibly allowing direct access to a binary. So many times you might have an application. This might be an app that you have purchased or have licensed, but it's not, you don't have the code to it or anything like that. It just happens to be existing on the same machine as where your Oak repository is. And let's say that application wants to read binaries to maybe extract a thumbnail or get metadata out or generate a rendition or something. You'd like to be able to have this directly access the file, but we don't allow that in Oak, and there are reasons for that. One has to do just the fact that we do deduplication, so that means that nodes get mapped to blob IDs, and there's not a really obvious way to do that mapping between what your path and node name is and the blob that corresponds with it. And then the other two here have to do with us being able to control the data. First of all, if Oak isn't in the middle, then we don't control access rights, which is one of the features that we're offering. So we need to be able to manage that request in order to control that people or that users that don't have access to blobs can't actually get to them. And then the other has to do with just simply supporting it. If the data is being changed out from underneath Oak, it's very difficult for us to claim that we can support what's going on with the data and that it's not getting corrupted. So we don't allow this. Instead, this native application is going to have to ask Oak for this binary, which will be downloaded and then brought right back to the file system where it already was, so that this can be modified. And if you're using something like S3, your scenario might be a little bit different. Like you might want to use a Lambda, but your problem looks basically the same. You're going to have to copy the file over somewhere before you can work with it. And that's also expensive in terms of time and money. So one thing we've talked about in the team is this idea of unmanaged binary support. And in order to do that, we had to introduce this concept here, the unmanaged binary. We, first of all, have to differentiate between a managed binary, which we didn't have to do before because every binary was managed before. So this is how unmanaged binary is different from normal ones. Basically, we're not going to manage it. That makes sense based on the name. So we don't do a bunch of things that you would normally expect. We won't, if we end up doing unmanaged binary, which I think we will, then unmanaged binaries won't be deduplicated. You can't garbage collect them. There's no indexing on them. And we don't even have the ability to guarantee that the file is even there. It might have been there at one point and then it got removed by somebody. So there are a lot of guarantees that you won't get with unmanaged binaries. But you will still be able to use Oak to service requests for them. So we'll store a reference to where that binary exists, and when a request is made for it, we can deliver like a download, for example. But one thing that we would be able to do that we won't do with managed ones is give you a URI to directly access the binary. So here's how those other scenarios would kind of work. I've merged the two repositories together into one from that scenario before. So how you would do this is you'd start with your existing repository here, and then you would use that bucket as your S3 data store location within Oak. When you bring up that new Oak instance, first of all, it wouldn't know about any of those, but you could write a very simple script that would traverse all of those and give them to Oak as unmanaged binaries. And then Oak would know the path, and you could generate your JCR nodes and all that stuff based on that. Once that had happened, that would only take maybe a few minutes instead of hours or days or more, depending on your repository size. And once that had happened, this Oak instance would immediately be able to service requests for that entire repository. Now, it's true that they are all unmanaged, so that's the trade-off that you would have to make. In the meantime, though, you can add new binaries into that repository as managed ones. So the trade-off would be, yes, they're not managed, at least at first. You could maybe do a thing later to import them. Whoops. But at least you can service requests for those right away. Here's the other use case. This where we had the native application that wants to directly access this. Instead, what it would do is ask, oh, can I get a URI for this resource? And if this resource is an unmanaged binary, then Oak will give back a URI for it, at which point the native application can access it directly. So if you have a library, for example, of video files that would be really expensive to process otherwise, then you can just directly access those files, if they're unmanaged, of course. Now, the status, let me get to this. This is an example of maybe how that would look. I stole this from Ian Boston, and I think if I give him credit, he won't care that I stole it from him. And also, I put adaptTo in here also, so if Bertrand got credit for this yesterday, then I think I should get credit today for putting that in there. But this might be an example of how it could work. We don't know how it's going to work, but something not very complicated. I was hoping to start on this, and I haven't had a chance to do that yet. So somebody in the Oak team, we hope, is going to start on this pretty soon. I'm not sure if it'll be me or not, but if you are interested in this and would like to help us out, then you should follow up with me or maybe Michael or somebody like that. We'll be at the Oak table later this afternoon. One feature that probably will be available pretty soon that's similar to this has to do with being able to get read-only access to binaries. We were hoping to be able to demo this today, and it's just not quite ready, but it's pretty close. I think it'll be available within just a matter of weeks or maybe a little bit more. I don't want to commit Ian to this. Ian's the one working on it. Here's how it would work. Remember, we can't even get a read-only access from this client to this binary because only we know the name, and Oak needs to be in the middle so that we can make sure that the client actually has access to that. But we would be able to serve a read-only URI, a signed URI, and two conditions. Number one, if the backend will support it, like S3 or Azure will both do this. File data store can't do that, but S3 and Azure can. The other way would be if the user has rights to the object. In that case, we could give a signed URI with a short TTL, maybe 60 or 30 seconds or something like that, and it would come as a Sling redirect. So this is kind of how that would look. The client would request the object to Oak. Oak would issue the signed URI as a redirect to the client, and then the client can get that binary directly from S3. Now this would work even if the binary was managed. We're not putting that restriction in this case because this URI has such a short TTL and it's read-only, so it doesn't matter. So that TTL would probably be configurable, but then the client gets to access that directly from the data store. One thing that's really nice about this is this offloads resource consumption from Oak, because now the binary is not going through the Oak JVM, but rather going directly from your S3, for example, in this case, to the client without going through the Oak instance. So that's what we've got, and we've got a little bit of time for questions.
Thank you. Any questions?
Hey, Matt.
Hey.
Conrad. Great talk. I had one, I actually have two questions, but I'm only going to ask one now.
Okay.
The unmanaged binaries, you said there won't be indexing of those. Is there a reason for that, or is it just to discourage their use?
I spoke with Thomas Mueller about that. My understanding from him is that we might be able to do that, but I'd have to check with him, honestly. What he told me is that we might be able to make it happen, but it would kind of depend on the cases, I guess. So I'd have to check with him to understand the actual reason. That's just something that he told me. Like I said, I'm new.
I bet if you find a request on Oak, it will be fulfilled. No.
First, we've got one in the back, and then we take Petron.
Well, one last sentence on that indexing topic. So the initial idea here is really to hook in an existing huge data store and don't deal with it at all. So if you hook it in and then start indexing it, and it's a, again, 10 terabyte store with garbage from the past, then you start indexing weeks before you can actually use it. So that is part of the direction I understood why we don't have it. But
But if it's like a tree falls in the woods, like if the content isn't findable, it doesn't actually exist.
true. Okay.
Yeah, but we're
The
not.
comment was if the content isn't findable, it's not very useful. Yeah. So, but if you navigate to it and it's indexed outside somewhere, but you can still hook it in very quickly. That was the idea.
We're not reading it in, though. We're just getting the reference to it. So we could read it in, but if we're going to read it in, then we might as well make it into a managed binary.
Thank you.
So, very interesting talk, thank you. Your composite data store made me think about RAID for hard drives. And I saw that you covered the RAID one with mirroring thing for high availability, and I thought about the RAID 0 thing, so to have high performances, and would you think it's possible, so first to have composite of composite, and then, yeah, to basically allow, if one data store is busy writing binaries, switching to another?
I haven't. So the specific use case you mentioned, I haven't thought about. There's nothing in it right now that would prevent such a thing, other than we'd have to have some way to know whether a delegate was busy or not. I have thought about the fact that we could have nested composites. I don't know how that would. I don't know how that would work exactly, other than it should theoretically be allowable, because the composite doesn't really understand anything about the delegates. It just delegates reads and writes to the one that it believes is the best candidate based on the configuration. So embedding one, it should work fine. I hope, but I haven't tried that yet. So yeah.
Yeah, by logic, I can tell about the S3 data store, so everything you have configured for caching and so on is still valid, and you can work with it. So I'm not sure if that applies on your case as well.
Thank you.
Bertrand?
Question for Conrad. Thank you first for this very interesting talk. So Matt is being cautious in saying we don't promise to deliver that in AM, which is right. But I'm interested because you're in touch with customers. How many or what percentage of your customers do you think would be where this feature would make a big difference?
I would put it the other way around. Currently, this is one of the limits to install large asset bases and operate them. So it's just a limit. If you don't remove it, customers will go some other technology stack. That's the way I see it.
Okay.
It's really a matter of when we do it, not if we do it.
Yes. Thank you.
Any other questions? Okay. So thank you very much for your talk. And yeah.